Hi, my name is Sophia Colosi and this is my presentation for Lab 2. In this lab, I'm going to use GlowScript code to simulate the trajectory of a star orbiting a black hole. The goal is that I will be able to determine the mass of the black hole. In order to do this, we need to find the net force on the star. We will have to apply Newton's second law and gravitational law. In curved motion, the rate of change of momentum can be broken down into parallel and perpendicular components. The same can be said of net force. The net force is equal to the change of momentum over the change in time. Below you can see that breakdown. Now let's move on to my code. On line 127, I changed my delta t to equal the number of seconds in a day and set the star's mass on line 123. On lines 167 and 168, I defined the initial and final positions using the momentum principle. Then I defined delta P and delta V, and finally defined the net force as dP dt on line 178 because of Newton's second law. Earlier I mentioned that we have to break down the net force into perpendicular and parallel components, so the next few lines are a reflection of that. Finally, on line 196, I defined the mass of the black hole by rearranging Newton's law of gravitation. Here you can see my code, and then when we get to the bottom, you can see how I arranged my force arrows. As you observe the simulated trajectory, notice the force arrows which are growing and shrinking. The orange arrow represents the net force and generally points toward the black hole. The pink arrow is the parallel force which points in the direction of the velocity and momentum. The blue arrow represents the perpendicular force. It always points to the center of the circle or perpendicular to the velocity. Notice the arrows get smaller when they're farther away from the black hole in the star's orbit. This makes sense because of Newton's law of gravitation. The average mass of the black hole found from the data came out to be 8.8 times 10 to the 33 kilograms. Now let's talk a little bit more about the parallel and perpendicular components of the net force and how they're different from the change of momentum and its components. We can't actually calculate the magnitude of the net force, but we know the star's position at every day of the year, so we can calculate the change of momentum. Now let's imagine that the black hole we have been working with was replaced with a different black hole at the same location. Let's also assume that the trajectory of the star doesn't change. Would we be able to tell the difference between the two black holes and find the mass of the new one? The answer is no. The trajectory doesn't change, so we know that the mass of the black hole can't change based on gravitational law. Imagine if our sun turned into a black hole. The Earth would continue to orbit as it always has, and we would all be dead, but the Earth's orbit does not change because the mass of the black hole would be equal to the mass of the sun. That's all I have. I hope you learned something new. Thanks for watching.